Okay. So where were we last time?
So we had discussed the triangular inequality.
Triangular inequalities. Okay. Graphical representation.
Yes, sir.
Okay. So we did polar form. Did we start the polar form? Okay. So today we'll discuss polar form and Euler's form in detail. Okay. So first of all, let's see the polar form once again. So I told you, since the complex numbers cannot be represented on a normal xy axis, on the normal Cartesian plane. So that's why we have a different plane for this, which is known as
Plane. Argand.
Argand plane, right? Argand or complex
Complex
plane.
plane.
So in this complex plane, this is a real axis and this is the imaginary axis, right? So if we have a complex number like 3 plus 4 iota, then the coordinates on the Argand plane would be
3,4.
3 comma 4, right? So 3 comma 4. This is the point on the Argand plane. So we have two major things which we need to remember for this. First one is the modulus, which we have already done, right? So what is modulus? If I have a complex number z is equal to x plus iy, then mod z will be equal to,
Under root x square plus y square.
okay. So in this case, if this point is x comma y, this will represent the,
Distance from the origin.
this is actually the distance formula, right? So distance from the origin to this point, this will be the value of
Mod z.
mod z. This will be the magnitude of the complex number, right? And the other thing which we need to remember is the argument, which is this angle theta. Okay. In this case, it will be equal to tan y by x.
Tan theta is equal to y.
Tan theta is equal to y by x, right? Can you see this? Since if I form this, if I complete this triangle OPQ, if I complete this triangle OPQ, then in this triangle OPQ, tan theta will be equal to y upon x, since the length of perpendicular will be y and the base is equal to x, right? So this is the value of tan theta. Understood? So if I have this modulus as well as the tan theta, which is the argument, then the polar form is actually mod z cos theta plus I sin theta, right? And I can also write this as r cis theta, right? Where r is actually the radius vector. Okay, we can also compare these complex numbers to vectors. Since this is a kind of a vector, right? Moving from this to this, directed vector, OP vector. Okay, so this will be the length of the vector, the modulus, and cis theta will represent this thing, cos theta plus iota sin theta. C stands for cos, I is iota, and then sin. So this is a shortcut, cis theta, right? So this is the very basic of polar form. Okay, so have you noted it down? Note down. So then the next thing is, I can have complex numbers in all the four quadrants, right? So let's suppose the complex number is in the first quadrant, like this. In the second case, it is over here, third quadrant, and this is the fourth quadrant. Okay. So we've been seeing this thing since straight lines, that whenever we are measuring an angle, it is always measured from the
X-axis.
which x-axis?
Positive.
Positive x-axis only, right? So this will be the angle. So this is the angle theta here. In this case, this obtuse angle theta, no, it's just theta 90 plus some other angle. Okay. this one angle, and in this case this angle. Okay, so whenever you are given a complex number like z is equal to x plus iy, you need to do one thing. You need to calculate the value of tan alpha is equal to mod y upon x. Okay, what do I mean by mod y upon x? You have to calculate the acute angle alpha, right? If I have -1 plus iota, this is the value of z. This will be equal to, what is the value of tan alpha? 1 upon -1, which is equal to 1. So in all the cases like 1 plus iota, -1 plus iota, -1 minus iota, and 1 minus iota, the value of tan alpha will be same. Can you see this? Since I am taking the mod of this, so positive negative sign don't matter. Is it clear? Positive and negative sign don't matter. I just have to see the ratio of this imaginary part and the real part, and that will always be equal to the modulus thing, and that is always going to come an acute angle. Can you see this? Since tan of an acute angle will be positive, right? So this is always coming positive. Now in this cases, in all these four cases, we will compare theta with alpha. In the first case, theta is exactly equal to alpha. Okay, so how will I come to know in which quadrant my complex number is? Can you tell me in all the four cases?
First one is in second quadrant.
Yeah, so first one is -1 plus iota. So the x-axis point will be, the abscissa will be negative, but the ordinate is positive. So it will be in the second quadrant. The third case, third quadrant. The fourth case, fourth quadrant. Right, x-axis is positive and the ordinate is negative. Right. So in all the cases we will compare theta with alpha. In the second case, theta will be pi minus alpha. Why is it pi minus alpha? In this case, alpha will be this angle, since alpha is always the acute angle. Right. In this case, theta is equal to minus alpha, and in this case theta is equal to minus of pi minus alpha or alpha minus pi. So these are the four important things which you need to note down. Okay.
अल्फा माइनस पाई लिखेंगे तो उल्टा नहीं हो जाएगा?
No, alpha minus pi, since this value is negative, this value is actually negative, so alpha minus pi will be negative. So you just need to remember these two, alpha and pi minus alpha. These are the negative counterparts of these angles. So this is minus alpha, this will be minus of pi minus alpha.
So where is alpha in fourth quadrant?
Alpha is this angle only. Okay. Alpha is the acute angle. In this case, alpha is this angle.
So then your by we have taken theta to be minus alpha.
Because we know that in trigonometry we learned whenever the angle is clockwise and anti-clockwise direction. In the anti-clockwise sense, the angle is always positive. In the clockwise sense, the angle is negative. Okay. So these are the four things which you need to remember. Written? Okay. So let's suppose we have z is equal to -1 plus √3i. Okay. So to convert this complex number into polar form, I need two things. First one is mod z and the second one is argument. Modulus and argument. So modulus here will be square root of 1 square or -1 square plus √3 square. So this is 1 plus 3, 4, square root will be 2. Then you calculate tan alpha. Tan alpha is equal to √3 upon -1, which is equal to √3, which implies alpha is equal to 60.
Pi by 3.
Yeah. So in terms of pi, it will be pi by 3. Now, this is not the argument. The argument will be
Pi
theta.
minus alpha.
Since this,
Pi minus alpha.
2 pi by 3, okay. So this is in the second quadrant, right? Can you see this? So abscissa is negative, this is positive, so this is in this quadrant, second quadrant. Okay, in the second quadrant, theta is equal to pi minus alpha. So it will be equal to pi minus pi by 3. Okay, this is the simplest way of doing it. So first you calculate alpha, which is an acute angle. Okay, these values are actually very easy to find. Okay, so next is z is equal to 2 plus root 3 plus iota. So in this case,
2 under root 2 plus root 3. सेट 2 बाहर फिर रूट अंडर रूट फिर उस रूट के अंदर 2 plus root 3.
no,
The mod z.
okay, mod z. What is the value of argument? So how will you calculate mod z? Square root of 2 plus root 3 square plus 1 square. Okay, so this will be square root of 8 plus 4 root 3. So you take 4 common. Is this what you're getting? 2 times 2 plus root 3 square root. And what is the value of theta? So first of all, what is the value of alpha?
1 upon 2 plus root 3.
So what is the value of alpha here? So you rationalize this thing, okay, you will get 2 minus root 3 after rationalization. Can you do this?
Yes, sir.
Rationalization part is easy, multiply by 2 minus root 3. In the denominator you will get 2 plus root 3, 2 minus root 3, which is 1. So you get tan alpha is equal to 2 minus root 3. If you remember trigonometry, what is the value of alpha here?
15.
15 degrees. Remember?
Yes, sir.
Tan 15 is equal to 2 minus root 3 and tan 75 is equal to 2 plus root 3. So value of alpha here will be 15 will be pi by 12. Okay. So how to convert an angle into radians? Remember, if you have 15 degrees, multiply it by pi upon 180 degrees. Okay. So this is angle alpha. So in which quadrant is this? First quadrant. So this is also equal to theta. Okay. So in both the questions, can you now write the two complex numbers in polar form?
Yes, sir.
So Z1 will be equal to 2 cis 2 pi by 3 and Z2 is equal to 2
Under root 2 plus root 3 cis pi by 12.
okay. So I think last time we did the Euler form as well.
Yes, sir.
E to the power, right? So how will I write these two complex numbers in Euler's form? So it's very easy. Yeah.
2 pi by 3.
And the other one is
2 under root 2 plus root 3 e to the power iota pi by 12.
so these are the two solutions, two answers. Okay. So you just replace this cis theta with e to the power iota theta. Okay. And I think we did the proof for this last time, right, with the help of expansions. Okay. So next part is What if you have to multiply two complex numbers? Did we do that?
Yes, sir. Multiplication and division.
Yeah, okay. So, after this, have you written this down?
Yes, sir.
Multiplication of two complex numbers we have done. Graphically?
No. ग्राफिकल मेथड से नहीं करना। एडिशन और सब्ट्रैक्शन में रहता है, सब्ट्रैक्शन नहीं रहता।
Z1 into Z2 we have done. Graphically.
No.
Yes? Yeah. Okay, we have done that. Multiplication we have done. So what if I have Z1 is equal to R1 e to the power iota theta 1, Z2 is equal to R2 e to the power iota theta 2. Then Z1 into Z2 will be equal to R1 R2 okay. So that means argument of Z1 into Z2 is equal to argument of Z1 argument of okay. I think we have done the properties as well.
Yes, sir.
Okay, good. So next is, what if you have this thing? 1 plus iota to the power 10. Can you calculate? How? Without actually expanding this. Calculate 10 pi by 5 e to the power iota 10 pi by 5. So first of all, write this term in the Euler's form. This can be written as root 2 e to the power iota pi by 4.
Whole power 10.
Can you do this?
Yes, sir.
First of all, calculate mod z, that will be equal to root 2. Okay. And the angle alpha will be equal to pi by 4 and theta is equal to alpha in the first quadrant. So we have to do power 10 of this, right? So this can be separated root 2 to the power 10 e to the power iota pi by 4 to the power 10. So this is 2 to the power 5, which is 32 e to the power I.
5 pi by 2.
What is the answer? Is this the answer? You can write this as
32 cos
yes, cos 5 pi by 12 or 5 pi by 2.
plus iota 5 pi by 2.
Okay. What is cos 5 pi by 2? What is cos pi by 2 then?
0.
0. So cos 5 pi by 2 will be 0 and this will be
1.
1. So answer is
32 iota sin नहीं बस 32 iota.
so sin pi by 2 is 1. So answer is 32 iota. Understood? Everyone? Okay. So you just expand this e to the power iota 5 pi by 2 by writing this into a polar form. Okay. So write this in Euler's form. Done? What's the answer?
Root 2 e to the power minus iota pi by 2.
No. So this is equal to 1 plus 7 iota upon, if we open the square,
3 minus
we'll
4
get
iota.
4 plus iota square minus 4 iota. Iota square is,
Minus 1.
so 1 plus 7 iota, 3 minus 4 iota,
Into 3 plus
3 plus 4 iota. So you get 3 minus 28 plus
5 iota.
upon,
25
so you get minus 25
plus 25
plus 25 iota
plus 25
upon 25. You take 25 common, you get,
minus 1 plus iota.
okay. So this complex number is minus 1 plus iota. What is the value of mod z? What is the value of tan alpha?
1 pi by 2.
What? Pi by 4. Okay. Okay. And the next thing which we need to do is to find out in which quadrant is this complex number lying. Which is that one?
Second.
Second quadrant. Then theta will be equal to,
Pi minus pi by 4.
so in Euler's form this can be written as root 2
E to the power iota 3 pi by 2. So we know pi by 2 is the pi by 2 value.
Yeah. Okay, good. So this is root 2 e to the power iota 3 pi by 4. Understood? Okay, next is a very typical problem. You have to calculate the value of iota to the power iota. So since both these are complex numbers, this should be a complex number as well. But on the contrary, this is a real number. Okay, can you find out the value of this real number? First of all, try to convert this iota into Euler's form. Okay. Then हाँ जी. Yes.
e to the power minus pi by 2.
Yes, good. So first of all, we need to see what we can do about this complex number iota. So mod z is obviously 1 because this has no real part. So this can be written like this. Okay. What is the value of alpha? Tan alpha.
1 by 0. Infinity.
Yeah, not defined or infinity. Alpha is equal to pi by 2.
Is equal to theta.
Yeah. So in the first quadrant, alpha is equal to theta, right? So I can write iota as 1 e to the power iota. So iota to the power iota will be e to the power iota.
Pi by 2 whole की power iota.
So this becomes
E to the power minus pi by 2.
iota square pi by 2. Iota square is. So since you can see that this is a real number. Okay. Now if you are asked iota to the power iota to the power iota and so on, can you do it now?
Yes.
How? You just make, yeah.
Iota.
So what is iota to the power iota to the power iota?
E to the power minus iota pi by 2.
This will be again a complex number, right? So if we have even number of iotas in powers, it will be a real number. In case of odd numbers, it will be a complex number again. So in case of iota to the power iota to the power iota, we get e to the power minus pi by 2 to the power iota, which is
E to the power minus iota pi by 2.
which is
A complex number.
okay cos minus pi by 2 plus iota
Sin
minus iota. Okay, this is equal to minus iota. Understood? Whenever we have e to the power iota theta, we can write this as cos theta plus iota sin theta. E to the power iota theta is cos plus iota sin. So that's how we wrote this. Okay. Next question is, we have cos pi by 2 plus I sin pi by 2 multiplied by cos pi by 2 square plus I sin pi by 2 square. You have to evaluate this up till infinity. Yes, karo. Do it. 7 pi by 8. AR?
first term into R to compensation.
This will be an infinite GP.
The A formula लगता है ना? So R upon 1 minus R.
R upon 1 minus R? No. What is it? A upon 1 minus R. So in this case, luckily R and A are both same. That's why this formula can also apply. So try to write this into Euler's form. What is it?
E to the power iota pi by 2 into e to the power iota pi by 4 pi by 8 and so on till infinity.
Iota pi by 8.
Into
This is going till infinity. E to the power iota.
5 formula 1 by 2 plus 1 by 4.
Okay, I'll write both the steps. Pi by 2 plus pi by 4 plus iota pi by 8 plus so on, and this is equivalent to plus up to infinity. So this is an infinite GP with the sum equal to, what is the value of sum here? A upon 1 minus R. So A upon 1 minus R. E to the power iota pi only. So this is half upon half. Okay. So e to the power iota pi can be written as cos pi plus iota sin pi. So this is 0.
Minus.
So answer is -1. Got this? Any doubt at any step? No? So for this you just need to remember the sum of infinite GP. Okay. So next is cube roots of unity. So there's a big topic about this cube roots, fourth roots, fifth roots of unity, and that topic is actually nth roots of unity. Okay, but the most important thing is, the most important one is cube roots of unity. So let's start with this one, then we'll move on. So what do we mean by cube roots of unity? Let's suppose, okay, first we understand, what if I had z square is equal to 1? What is the value of z? I'll have two values, plus minus 1. So z will be equal to, what if I have z cube is equal to 1?
Z equals 1.
Just one solution. I'm bound to have three solutions here.
0, 1.
Huh? Can you tell me what are the three different solutions for this equation? Z cube is equal to 1. One of them is z is equal to 1. The other two will be complex. Try to find the complex solutions of this. So how do I solve z square is equal to 1? What do I do is, I keep this 1 on the LHS, make an equation like this, then I get z minus 1 into z plus 1 is equal to 0, either first factor 0 or second factor 0. So we get z is equal to 1 minus 1. Similarly solve the other one, this one. I under root, yeah. Can you write these two in the Euler's form? Yes? Okay, do it. So the simple way of doing this is z cube minus 1 is equal to 0. No, plus AB. So this is z minus 1, z square plus z plus 1. So this is a cube minus b cube is equal to a minus b, a square plus ab plus b square. So either z is equal to 1, this we already knew, right? So the two roots of this equation are z is equal to minus 1 plus minus root 3 iota upon 2. Minus 1 plus minus root 3 iota upon 2. Understood? So can you write these two roots? So first root is z is equal to 1. Second one is z is equal to minus 1 plus,
root 3 iota by 2
and the third one is z is equal to.
minus 1 minus root 3 iota by 2.
Can you write these? Okay, all these three in Euler's form. Try all three of them. So the modulus of all these three will be equal to 1. Okay, since they are cube roots of unity, right? And if you take modulus over here only, you will come to know. Like if you have z cube is equal to 1, you take modulus on both sides, then modulus of z cube is 1 or modulus z cube is equal to 1. So the value of mod z will be equal to 1. Okay, that's for sure. So in all the three cases you can check as well, the modulus is equal to 1. You just need to find out the angles. Okay, so here tan alpha is equal to root 3. Root 3. So alpha is equal to pi by 3. Even here alpha is equal to pi by 3. And here alpha is equal to what?
0
So this is 1 plus 0 iota.
0 by 1 0.
So this is 0 upon 1 here. So alpha is equal to 0. So here theta is equal to 0. Here theta is equal to which quadrant is this?
Second, pi minus pi by 3.
So this is pi minus alpha, which is equal to
2 pi by 3.
2 pi by 3. And in the third case, theta
Minus pi by 3. Theta is equal to minus pi by 3.
minus 2 pi by 3.
Third quadrant.
So this is the third quadrant. So theta is equal to minus of pi minus alpha, which is equal to minus 2 pi by 3. चल रहा है सही? Okay. So theta is equal to minus 2 pi by 3. So the three complex numbers which we have is, the three complex numbers are, first one is z1 is equal to e to the power iota 0. Okay. Second one is z2 is equal to e to the power iota
2 pi by 3.
2 pi by 3, and z3 is e to the power iota,
Minus iota 2 pi by 3.
and this can also be written as e to the power iota 4 pi by 3. Okay, this is the methodological way, this is the way of method to write this thing, but since the angle, if you see, the reflex angle will be 4 pi by 3. Okay, so why am I writing this as 4 pi by 3? I'll explain you. These are the correct ways of writing it. Okay, e to the power this iota 0. Yeah, we can write this as 1. But there's a reason I'm writing it like this. So the reason is, when you represent all these three complex numbers on the Argand plane, first complex number is this one, second is over here, third is over here. Okay, so the angle between all these three is always equal to 2 pi by 3. Since you can see that angle between 0 and 2 pi by 3 is 2 pi by 3. This can be written as e to the power iota 4 pi by 3, right? So this will be the angle, 2 pi by 3, again 2 pi by 3. Okay, so when you're writing cube roots of unity, you need to divide your quadrant system into 3 equal angles. Okay, so that's the trick, that you make a triangle equilateral. Okay, and the 3 vertices of the triangle will be the cube roots of unity, and you're starting from here always. Okay, now this complex number e to the power iota 2 pi by 3 is known as omega, and the other one is known as omega square. So this is a very important thing. The first complex number, which is over here, this is 1. Second complex number is omega, the third one is omega square. Okay, so these are the cube roots of unity, 1, omega and omega square. Okay, this is just a representation like iota. Okay, so for -1 plus, have you made this thing? So the 3 cube roots of unity are z1 is equal to 1, okay, is equal to e to the power iota 0. Second is z2 is equal to -1 plus root 3 iota by 2 is equal to e to the power iota 2 pi by 3. Yeah, so z3 is -1 minus root 3 iota e to the power minus iota 2 pi by 3 slash e to the power iota 4 pi by 3. So the z3 was this complex number. So this angle is -2 pi by 3. If I'm measuring the angle, okay, in the clockwise direction, it will be -2 pi by 3, but in the anti-clockwise direction it will be 4 pi by 3. Why? Because the sum of the two angles will always be equal to 2 pi. Okay, since the sum of the angles is 2 pi, this is -2 pi by 3, so other one will be 2 pi minus 2 pi by 3, so it will be 4 pi by 3. Okay, so the other angle will be e to the power iota 4 pi by 3. Now I told you this is equal to omega and the other one is omega square. Now the beauty about these two complex numbers is, if you square this thing, you will get this thing. Okay, if you square this complex number, you can check it out as well. You can square this thing and you will reach over here. Okay, and if you square this, you will get this one. Okay, so why is it this happening? Because actually these are cube roots of unity, right? So if I take cubes of all three, so 1 cube will be equal to 1, omega cube is equal to 1, and omega square cube is also equal to 1. Okay, so this is pretty natural since they are satisfying this equation, z cube minus 1 is equal to 0. These are the 3 roots of this equation. So if the 3 roots are 1, omega and omega square, right, then they can be written as 1 omega omega square, right, and the cubes of these 3 will be equal to 1 again, right. So now let's see, if I square omega square, so omega square will be equal to omega to the power 4. This can be written as omega cube into omega, so this is equal to omega. So omega square will be omega square and omega square will be omega, right. So they are like this. So if you square one, you will get the other. If you square this, you will get the other. Understood? Okay, so we'll draw the diagram once again, so don't worry. So these are the 3 complex roots of unity, cube roots of unity. Any doubt till here? Sure? Okay. So now we have seen that they are actually satisfying the equation z cube minus 1 is equal to 0. So this is a cubic equation, right? This can be completed like this: z cube plus 0 z square plus 0 z minus 1. So why am I completing this thing? So that you don't get confused. If I am adding the three roots of this equation, cubic equation, what will be the value? What will be the sum of roots here? 0. What will be the product of roots? 1. So sum of roots here will be equal to 0. So 1 plus omega square will be equal to 0. So how am I getting this? Because in a cubic equation, ax cube plus bx square plus cx plus d, the sum of roots is equal to minus b by a. Remember, this is, yes, okay. So the sum of roots will be equal to minus b by a. The value of b here is equal to 0. So this is a very important thing. 1 plus omega square is equal to 0. So always remember this, that omega plus omega square is always equal to minus 1. This can also be proved. Is this minus half plus root 3 iota by 2? Other one is minus half minus root 3 iota by 2. And if you add these two, you will get minus 1. Okay. So this is equal to minus 1. Got this? And if you take product of roots, that will be 1 into omega square, and this is equal to plus 1. Since here product of roots will be equal to minus d by a. So omega cube is equal to 1. Okay. So you just remember this property. This is very important, that omega plus omega square is equal to minus 1. Okay. So let's move on. Yes? Any doubt? What's going on? Who's calling sir, sir, and then not replying? Okay. No doubt? Okay. So, in case of cube roots of unity, like z cube is equal to 1, the three roots will be like this: first one, second one, third one. Okay. If I have z to the power 4 is equal to 1, the four roots will be like this: first root, second root, here is the third root, this is the fourth one.
The magnitudes are the same.
Yeah, magnitude will be same. Magnitude is always equal to 1.
अगर z4 is equal to 4 then
Z to the power 4 is equal to 2. Yeah, so magnitude, if you take magnitude on both sides, what will you get? So mod z to the power 4 is equal to 2. So mod z is equal to 2 to the power 1 by 4. Right? So in this case, since this is a magnitude, this should be a real number. The cases, in all the nth root of unities, the magnitude is always equal to 1 for each and every root. Okay. So just see the symmetry here. In the case of cube roots, you are making the three roots like this. Okay. So angle between them will be 2 pi by 3. In this case, angle between them is pi by 2. Can you make the fifth roots of unity? So you have z to the power 5 is equal to 1. So this means this equation has how many roots? 5 roots. First root is very obvious. It is very well seen that the first root is always equal to 1. As you can see that, right? 1 satisfies all these equations. So first root always start from here. This is the first root. Can you tell me what are the other roots? Can you plot them graphically? So see, I'll tell you a trick to do that. Whenever you are calculating nth roots of unity, then the angle between roots is equal to 2 pi by n. So this is a very obvious thing also. Since I'm getting n roots, I'll have n partitions over here. Whenever I have 4 roots, okay, I will have 4 angles, okay, which are adding up to give you what? 2 pi. The sum of all these 4 angles, and these 4 angles are equal, the sum of all these 4 angles will be equal to 2 pi. Then each angle will be equal to 2 pi by n. Now here I'll get 5 angles, 2 pi by 5, which is actually what? 72 degrees, right? So first will be here, second 144 will be here, next is 144, next is 144 plus 72 is 216. So 216 will be in the this quadrant.
Yes, sir.
So it will be the mirror image of this. Yeah. Since the angle between all of them is 2 pi by 5, right, which is 72. Angle between these two is 2 pi by 5, and these two is also 2 pi by 5. So this is also 72, this is also 72. Can you make z to the power 6 is equal to 1? Make it. 60, 60. So they will form a hexagon. Okay, the first one are forming an equilateral triangle, second one are forming a square, third pentagon, fourth is hexagon, and all of these are regular polygons. Okay, so the angle between them, the sides, the angles, they are all the same. So z to the power 6 is equal to 1 will be, first is this one, second, third, fourth, so these are the sixth root of unity, right? So angle between them will be pi by 3, here it is 2 pi by 5. So simple formula is 2 pi by n. Okay, so here you can see that if you're getting 3 roots, the 3 roots are 1 omega omega square, The sum of these three roots is 0. In this case you are getting 4 roots. Actually these 4 roots are very easy to find. First root is 1, second root is iota. Why is this iota? This is okay. If you write iota in the polar form, on the Euler form, it will be 0 plus iota, right? So 0 plus iota, which means
A point on the y.
real part is 0 and the imaginary part is 1, right? So this will be on the